So hello guys, welcome back to our YouTube channel. So I am Dheeraj from Smart Interviews and today we will be solving questions from LeetCode Contest. Okay guys, let us solve the second problem of the LeetCode Contest. Okay, so this is the second question, which is shortest distance after road addition queries 1. This is the first variation. Okay, so let us have a thorough discussion on the given question. So the question says you are given an integer n, okay, and you are given a matrix of queries or a 2D integer array of queries, okay. So there are n cities. Basically, there are n cities. So the first city starts from 0 and it goes till n minus 1, okay. So it starts from city 0 and it goes till n minus 1, okay. Now initially, there is unidirectional road from city I to city I plus 1. Like, what does that mean? Unidirectional. What is the meaning of unidirectional? Unidirectional means, to put it in simple terms, this is nothing but a one way. Let's say we have two cities, city A and city B. So there is a unidirectional road from city A to B, means there is only one way. You can go to B from A, but you cannot go to A from city B. So then what do we call this? This is called as bidirectional, both ways, bidirectional. Okay. So in the given question, it is mentioned unidirectional, which means from city I, you can only go till I plus 1. Okay. So in this way, for all the nodes. So in this way, for all the nodes. So here, he mentioned something which is uh, there will be queries of phi. Queries of phi is nothing but u of phi comma v of phi. It represents the addition of new unidirectional road from city ui to vi. After each query, you need to find the length of the shortest path, from city 0 to city n minus 1. Okay, you need to simply return as an array. Let us call it as answer. Okay, so I will explain. So just focus on this. So here you have n nodes, right? Here n is nothing but 5, which means you have 5 cities. So city 0, city 1, city 2, city 3 and city 4, 0 to n minus 1. Done. Now you are given q queries. Now before that, see here, how many cities are there? There will always be a road from city 0 to city I plus 1, which is nothing but 0 to 1, 1 to 2, 2 to 3, 3 to 4. There will always be a road for the adjacent cities initially. Okay. Now if you're done with that, now see here, you are given a query, right? Which is nothing but the first query is 2 comma 4. What is the meaning of that? The meaning of that is, so here 2 comma 4, let me write it down, 2 comma 4. So let me call 2 as 2 and 4 as from. Sorry, 2 as from, 4 as 2. Which means there is a new road which has been formed from city 2 to the city 4. Okay, from the city 2 to the city 4. Now, assume, now here we have constructed a new road from city 2 to city 4. Can you tell me the shortest path to reach the city 4 from city 0? The shortest path is this one, right? 0 to 1. Okay. The shortest path is 0 to 1, 1 to 2, then 2 to 4, right? So if I go like this, 0 to 1, 1 to 2, and then 2 to 4, what is the output for this? How many roads did I pass? This is the one road, second road, and third road. So I have the shortest path is simply nothing but 3, right? But what if you don't use this new road? Then you will be going from 0 to 1, 1 to 2, and then 2 to 3, and then 3 to 4. What is the shortest path now? 4, right? So among these two, we need to simply return the minimum. What is the minimum here? 3. So we will simply return 3 as our answer. So here is the first output that we want. Okay. So now we have constructed a road, which is done. Now, so we are done with the first query. Now comes the second query. There is a new road from city 0 to city 2. Okay. Which means this one. There is a new road from city 0 to city 2. And then this is already existing road, which is nothing but we have constructed in the previous query itself. Okay. So now tell me, what is the shortest path to reach the node 4 from node 0? I can simply go like this, right? From 0 to 2 and then 2 to 4. What is the shortest path? What is the length here? Like the amount of roads, 2, right? So we will simply return 2 as our answer. And now we are done with the second query as well. Now for the third query, we have constructed a new road from city 0 to city 4. City 0 to city 4, which is directly from source to destination, right? Now what is the shortest path? Here we have 3 options, right? So first one is you can go from 0 to 1, 1 to 2, 2 to 3, and then 3 to 4. Or you can go from 0 to 1, 1 to 2, and then 2 to 4. Or you can directly go from 0 to 4. Among all these paths, which one is the shortest path? Obviously, the last one, right? So in the third query, we have constructed a new road which goes from city 0 to city 4, right? Now tell me what is the shortest path to reach from city 0 to city 4. And here it is simply nothing but 1. By considering this one road, you can go to the destination node, right? So here our output is 1. So this is the overall question. You are given a value n, you are given q queries. For each query is indicating that you are constructed a new road from city I to city j. Now tell me what is the shortest path from source 0 to source n minus 1. That is the overall question. And here if you look at the second example, for better understanding, here there are 4 nodes, which means there are 4 cities starting from 0 to 3. We have constructed a road from 0 to 3. Now tell me what is the shortest path? I can obviously consider this one road itself, right? So here our answer is 1. Now what about if I constructed a new road from 0 to 2? Still I will consider only the longest road, which is 0 to 3, right? Which will have the shortest path. Hence my answer is 1 again, right? So this is the question. Now tell me, what is the logic that you guys are able to came up with? What kind of logic are we thinking here? If you look at the question again, each query is nothing but a road that we are constructing from a particular city to a particular city, right? And now we need to simply find the shortest path from city 0 to city n minus 1. So we have multiple shortest path algorithms, right? We have multiple shortest path algorithms. We can use any one of them. Can we use any one of them? Is it possible? Now, if you look at this, whenever you are trying to solve any problem, focus on the constraints. Here, if you look at the constraints, n value is starting from 3. In the worst case, it can go till 500, right? Which is nothing but we will be having a cities from 0 to 500. That's it. Okay, guys. So let us discuss the BFS solution here. Okay, how can we use BFS to get the length of the shortest path from source to destination, or from city 0 to city n minus 1 after each query? Okay, so initially to implement BFS, we definitely need a queue, right? Because with the help of queue only we can iterate. So just a second. So assume this is our queue here. Okay, this is our queue, and we have created a distance array of size n. Initially, at each index, we are having a default value of -1. Okay, -1 is indicating that I have not reached this node yet. Okay, -1 means I have not reached this node yet. Okay. So now let's see how BFS is going to help us to find the shortest path from city 0 to city 4 for each query. So first, let us do the first query, which is I need to make a link from city 2 to city 4. Okay. How do we make this link? We will discuss that later. But for now, let us simply put our main focus on the logic. Now assume that I have created a link from city 2 to city 4. Okay. Now what I will do is after making each of this link, or after I created each of this road, what I will do is I will simply do a BFS from city 0. I will simply do a BFS from city 0. So first what I will do, I will simply push source node, which is 0, into the queue. Now tell me, what is the length to reach city 0 from city 0 itself? The length is 0, right? Right. Now, from city 0, how many links or how many cities can I visit? There is only one city that I can visit from city 0, which is city 1. So what I will do, now, before that, here I can see from city 0, I can visit only one city, which is city 1. And I also need to check, did I visited this city 1 or not? If and only if I have not visited this city, then I will visit. Okay. So here it clearly looks I have not visited the city 1, right? So what I will do, I will simply pop this element and push 1 to the queue. Okay. And what is the distance to reach city 1 from city 0? It is 1, right? So we are done from source node, which is 0. Now I am present at city 1. Now I will do the same thing. I can visit city 2 from city 1, but I also need to check, did I visited city 2 or not? I will explain why we are checking this condition, why we need to check whether we have visited the city or not. I will explain that later. But let us just put our main focus on this logic. So from city 1, I can visit city 2, and city 2 is not being visited yet. So what I will do, I will pop 1 and I will push 2. Okay, city 1 is done. Now what is the length of visiting city 2 from city 1? Exactly, it is nothing but 2, right? So now from city 2, I can visit city 3, right? I can visit city 3 and I can visit city 4 as well. So first let us simply put our main focus on visiting city 3. So what I will do, I will simply go to the city 3. Okay. Now what is the distance here? This becomes 3. Now see here. From city 2, I can go to city 3, and apart from visiting city 3, I can also go to city 4 as well. So I need to go to the city node 4 as well. So here, if I visit, and let me put it here, if I visit city 4, what will be the length here? Exactly. So till here 1, till here 2, from here to directly city 4, the length turns out to be 3 itself. 3 itself. Now I will remove the node 2. Now if you look here, when I pick the city 3, from city 3, how many cities can I visit? City 4. But city 4 is already visited. City 4 is already visited, which means, do I need to visit the city 4 again? No, right? City 4 is already visited. I don't need to visit the city again. Hence, I can simply remove this node. From 4, are there any cities? First of all, there are no cities. Hence, I can simply pop this node from our queue. Now here, our answer is nothing but distance of n minus 1, which is 3. Right? Is that the expected answer for our first case? 3. Now why this is working? Now let us try to understand why this is working. I will explain you in a much simpler way. Let's assume that I have a few nodes from A to B and then B to C, C to D, and then D to E, and then E to F. Okay, so here let's assume I have added a new road from city C to F, from city C to F. Okay, so if you see here, from A I can only visit one node, which is B. From B I can only visit one node, which is C. From C I can visit two nodes. One is I can visit C to F, or okay, I can visit C to D, or I can visit C to F. The thing with BFS is BFS goes level by level. BFS goes level by level. In DFS, if you see, first what will DFS do? From A it will go to B, B it will go to C, C to D, D to E, E to F, and then backtrack. If there are any nodes, it will tap. But in case of BFS, it goes level by level. So here from C, I can go to two nodes. One is to D or one to F, right? So first what I will do, I will go to D and then I will go to F. Since I have reached F, I will mark it as visited. And when I reach the city F from E, it has been already marked, right? Which means some other road. With the help of some other road, I have reached the last node. So I don't need to calculate this current length again, right? So let us write the code for this logic. Okay. So first one. So if you see here, so what is the first thing that we need? We need to return the result in the form of an vector, right? So let me declare a vector of called as answers, and then I need a map of int comma vector. So I told you, right, how are we going to store this length? So here, this map of int, which is nothing but the first field, indicates the node. If you see here, from 2 you can go to 4, and from 2 you can go to 3. So we are going to store this data in the form of int comma vector int, which is nothing but 2 comma 3 comma 4, like this. Okay, so when you pass this value to the map, you will simply get a vector of nodes or vector of cities that you can visit from the city to. Okay, so here you can see how I am going to implement it. So here I have simply declared a map. Okay, now in the question he has mentioned from city to city I+1 there will be a link by default, right? So what I will do, I will iterate from I equal to 0 till n-1 I plus plus map of I dot pushback of I plus 1. So what is this piece of code is doing is I am simply making a connection between city I to city I plus 1. Done. Now I need to iterate on the queries. Okay, let me call it as queries. Okay, now here in each query you have two values. One is from, which is from which city you are making the new road, right? So here QR of 0 to which city, QR of 1. Done. So I will simply insert this into my map of from dot pushback of 2. If I do this, I have created a new road in the map, okay, in the graph. Done. Next, I will simply declare a queue because BFS works on the queue. And then, as we have discussed, we need a distance array which has of size n and default values are -1. And we have seen that distance of 0 itself is 0, and then we will push the source node which is 0 into our queue because 0 is the starting city, right? Because from there we need to calculate the shortest path. And now while not q dot empty, I will get the current node. Okay, current node is equal to q dot print and then q dot pop. Okay, so here I have a node. Let us assume initially it is 0 node. From 0 node, how many nodes can you go, or how many cities can you reach from 0 node or from city 0? I can simply check that from, so how many neighbors are there basically. So I can simply check that from map of current. Okay, so first thing is, whatever the node that I can visit from this city I need to check this city has been visited or not. If it is visited, I don't need to consider, because some other shortest path has already visited this node. So I should not considering, so I should not be visiting the city again. Okay. So to check that, distance of neighbor is, if it is equal to -1, if it is equal to -1 only, I will go further, which is distance of neighbor. Oh, sorry. Distance of neighbor is equal to distance of current plus 1. That's it. And then I will push this neighbor into my queue. And what is the answer? Dot push back of distance of n minus 1. For each query, I will simply push back my result. And here I will simply return the answer. That's it. Let us run the code. Accepted. Submitted. So the question is pretty much simple, right? This is the second one. If you like this video, please do share, like, subscribe, and see you in the next video.